Hey guys, we're going to be looking at mod 21.3 today. So we're going to be looking at factoring special cases and solving equations when doing so. And so we're going to do something a little bit different though. We're going to just look at example 2, which is on page 1012 and 1013. And so we're going to go ahead and get started. So we're looking at factoring a squared x squared minus b squared equals 0. Okay, so again, we are going to be solving because we have this piece here. And so if we recall that a difference of squares can be written algebraically as a squared minus b squared and factored as the quantity of a plus b times the quantity of a minus b, we know that we have difference of squares. Okay, so if we look at this box here, so I want you guys to box it, highlight it, do whatever you need to do so you see difference of squares. And we're actually going to be looking at examples here. And so if we have x squared minus 9, well, if we break down x squared, we actually get x and x. And then when we break down that 9, you know, that perfect square, we have plus 3 and minus 3. Okay, again, we're going to look at this 9 here. We have plus 3 minus 3. We have 4x squared. Well, 2x times 2x is going to give us that 4x squared. Okay, now we have 9x squared, which gives us 3x and 3x. And then we're going to take a look at that negative 1, which we have plus 1 and minus 1. And so something that I want you guys to notice quickly is that there are no middle terms when it comes to perfect square binomials or the difference of two squares. Okay, and so we see here with c squared x squared minus d squared, well, that's going to be cx squared minus d squared, which gives us the quantity of cx plus d times the quantity of cx minus d. Okay, and so now remember, anything I'm writing down, you guys need to write down with me. And so we're actually going to look at example 2 together. So factor each difference of squares. And so if we look at a, okay, right now I want you guys just highlighting as I talk about it. We have x squared minus 49. Well, we recognize that we have 1x squared, which is a perfect square, and we also recognize that 49 is a perfect square. And so this is actually just going to be, right, if we're looking at a squared minus b squared, well, x squared is a, 49 is b, which is where we run into x squared minus 7 squared, which is going to give us x plus 7 times x minus 7. Okay, if we rewrite it in factored form. And so the factored form of a squared minus 49 is going to be x plus 7 times x minus 7. Okay, so now I need you guys to do the next one with me. Instead of just highlighting, you're actually going to write it out. And so we have 49q squared minus 4p squared. And so if we're taking a look at that, the first thing that we actually need to do is look at 49, and how are we going to break that down? Well, the perfect square is going to be 7 times 7, and so we will have 7 squared. And then if we break down q squared, we get q squared. Okay, and then I'm going to break down my 4p squared, and so I get 2p, and then the quantity of that squared. Okay, and so if I actually work that out, I should get, let me go ahead and switch colors here, I should get 7q and 7q minus 2p plus 2p. Okay, so the factored form of 49q squared minus 4p squared is 7q minus 2p and 7q plus 2p. Okay, so the book does it a little bit differently. I would have just done it like this. So we have 49q squared minus 4p squared. Well, I know that both of my squares on my variables are going to break apart and give me 1 each. Let me put this a little further apart. And then if I look at 49, I know that I need 7 and 7 to make that true. And if I look at 4, I know I need 2 and 2, since we are looking at perfect squares or difference of squares. And I need plus and minus because we do not have that middle term. And so this is the same exact thing that we get when we do it the way that the book did it. And so again, like I usually tell you guys, whatever you're comfortable with, go ahead and use that. Okay, so let's go ahead and go down. We're gonna try your turn, and we're gonna look at number 7. And so if I break this down, well, what's the first thing that we can do with this? Well, the first thing is we can take out a 9y squared. And so let's rewrite that. So I'm going to take a 9y squared out. And I am left with 9y squared minus 1. Well, now I can go ahead and continue. And so I am going to break this down even further. And I know if I'm looking at this 9, I'm going to need 3 and 3. And of course I have y because I have y squared. And my perfect square of 1 is going to be 1 and 1. And then I am going to have opposite signs. And I still have this 9y squared out in the front. Okay, and so this would be our final answer. So it's just being able to recognize that, okay, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on and so forth. And so you guys do get a calculator, but make sure that you know, I would say probably up to about 9. Because if we continue on and go till 9, this is what we get. Okay?